So this is question 7 on 191. A roller coaster car with mass 640 kilograms moves along the track shown in figure 8. Assume all friction is negligible. A. Is the mechanical energy of the roller coaster conserved? Explain your answer. Yes, the mechanical energy of the roller coaster is conserved because there is no loss of mechanical energy as the roller coaster goes down the roller coaster, because as it increases in speed by going due to gravity, it decreases in height. So as kinetic energy increases, gravitational potential energy decreases proportionally, so it stays at with the same total mechanical energy. B. If the roller coaster starts from rest point A, what is the total mechanical energy at point A? So if it starts at rest, that means there's no kinetic energy yet. So we can just use the formula for gravitational potential energy, which is mass times gravity times acceleration due to gravity times the difference in height, which is 640 times 9.81 times 30, which is equal to 188,352 joules. C. What is the total mechanical energy at point B? Since we know from part A that mechanical energy in the roller coaster is conserved, B would be the same. C would be the same thing as B, because there's no energy lost or gained due to conservation. D. Calculate the speed of the roller coaster when it reaches point B and C. So to do this, you have to find the velocity after isolating for the kinetic energy. So you know the total energy since energy is conserved. So 188,352 is equal to the gravitational potential energy plus kinetic energy. So after going through all the equations and isolating for velocity, you get 17.155 meters per second. With point C, because there's an elevation of 0 from the ground, you'd only have to solve for kinetic energy, or solve using the kinetic energy equation. So you isolate for velocity and you'd get 24.261 meters per second. With E, so if the car starts with a speed of 12 meters per second at point A, you're gonna have to add it starts with more energy because of the new kinetic energy. So you have the gravitational potential energy that you already got from part B. So you just have to add the kinetic energy that you can calculate using the equation and end up with 2,34432 joules. To get to part B, you do the same thing you did part D. So isolate for kinetic energy first, and then isolate for the velocity, and you get 20.936 meters per second. And then same thing with point C. So because there's 0 elevation, you'd only have kinetic energy, so just isolate for velocity and you'd get 27.067, and you're done.